All right, everyone. The second half of chapter 3 is all about matrices. And basically, the big objective here is to take our systems of equations and develop a more efficient way to solve those problems. So, before we get into how to solve using matrices, we need to figure out what are matrices. And that's what today and tomorrow are kind of all about, and basic operations with them. So, looking at this, operations with matrices, we're just going to go over the first portion, which is how to set up a matrix. All right. So we're looking at Caitlin wants to attend one of 3 Iowa universities. She gathered information about tuition, room and board, and enrollment for the universities as pictured here. All right. It says we just want to organize the data into a matrix. So literally, all you do is take the numbers out of the problem and put them in a matrix form. 52, 59, 58, 72, 50, 62, 80. And then the enrollment column is 26,160, 30,409, 12,609. So we have literally just organized the data into matrix form. So part B, it says find the average of each column and interpret the result. So if I find the average of each column, my first column, the average is 5,918. And I'm going to round to the nearest dollar just to make life easier. 5958 plus 7250 plus 6280, 6496, 26,160, 3409, 12,609, and divide by 3 is 23. Again, we'll round to the nearest person. No partial people in this. All right. So it says interpret the result. Well, the first number, 5,418, is the average tuition of the 3 schools. 6,496 is the average room and board of both schools. And then the average of the third column is the average enrollment of the 3 schools. So that makes sense. When we look at the next question, it says, would adding the data in the rows be meaningful? Well, if we look across our information, all right, we look across, we have dollars, 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 and then that's people. Those have different labels. So would the information be meaningful? No. It'd be like combining apples and oranges. It doesn't make sense. Would adding the data in the third column be meaningful? So a little different situation. If I went down the third column, would that be more meaningful? The answer is yes. It would be. All of those are people, so this would be total enrollment of the 3 schools. Okay? So, setting up matrices, essentially all it is an organization of numbers stripped of any labels. All right? So it's just straight up numbers. If you've ever used Microsoft Excel, that's exactly what it is. It's a giant matrix. So, second part of the day, we're going to look at using operations. Okay? You can look at this chart up here if you want about adding and subtracting matrices, or you can just use your intuition. And it's probably a lot easier if you just use your intuition. All right? So checking out things. We want to add C plus E. Well, C is 8, 6, and E is negative 7, 2. So if I want to add those, I'm guessing you probably already know what to do. But if you don't, what we do is we add corresponding entries in our matrix. So what's 8 plus a negative 7? 1. What is 6 plus 2? 8. that is my answer. All right. Sometimes we might have a situation like A and C, where we have 16, 2, negative 9, and 8. And we're adding that to the matrix 8, 6. And some of you might say, well, why don't we just add 16 and 2 and 8 together, since they're all in the top row, or negative 9, 8, and 6. Well, in that situation, with adding and subtracting matrices, they need to be the exact same dimensions. So this problem is actually impossible. Okay? If you want to add and subtract matrices, they must be the exact same dimensions. All right, we'll skip C for now, and we'll jump into D. So we have 16, 2, negative 9, 8. And we're subtracting B, which is negative 4, negative 1, negative 3, negative 7. Lots of negatives, so we need to be careful here. All right. To get the answer, we have 16 minus a negative 4. Well, what's 16 plus 4? 20. 2 minus a negative 1, or 2 plus 1 is 3. Negative 9 minus a negative 3, or negative 9 plus 3, is negative 6. 8 minus a negative 7 is 8 plus 7, which is 15. Okay. So keep in mind, as we are adding and subtracting matrices, we add and subtract corresponding entries. All right. If we skip ahead, skip E for now, look at D, or look at F, sorry. C plus D, we have 8, 6, and we're adding 4, negative 9. Again, looking at these matrices, they are not the same. We have a 2 by 1 and a 1 by 2 matrix. This is a 2 by 1. This is a 1 by 2. They are not the same dimensions. So again, if they aren't the same, this problem is impossible. If only your math teacher could spell. All right, moving on. All right, we also have scalar multiplication to explore today. All right, this is super, super straightforward. All right, all you really need to think of is distributive property. All right, so on example 3, if I want to find 4r, literally 8, 6, negative 16, 4, 19, those should be brackets. All we're doing is we're multiplying everything by 4. So we have negative 48, 32, 24, negative 64, 16, and 76. All right, so the last thing, if we put everything together, scalar multiplication and addition, subtraction, what we wind up with is negative, or the opposite of negative 9, 5, 6, negative 2, and we're subtracting 2b, which is 7, negative 4, negative 3, and 1. All right, a couple ways to do this. I would take care of the subtraction first and then change it over to addition. So we have 9, negative 5, negative 6, and 2. Then I'm going to distribute a negative 2 to everything. So I have negative 14, 8, 6, negative 2. So my answer is negative 5, 3, 0, 0. And that's it today. Homework is pretty straightforward. Best of luck.